So here we have an online bank. Here we can search for our credit cards, like so, or we can just put this value here, and now instead of the credit cards, then we would see all of the usernames and passwords of all of the users of this application. Now what just happened? So SQL, or the structured query language, is the language that applications use to talk with their databases. For example, we have a web application that takes a username and a password and then tries to log in a user. We would do that by sending a query to the database asking, hey database, does a user with this email and password exist? If so, we would let the user in. If not, then we wouldn't. And this is what the query would look like. So SQL is simple. It kind of looks like English. So we would say select, that is retrieve data, star, that is for all of the columns. We could specify like ID and the first name here, but let's just say star for all of those, from the user table. And then we would also want to add a condition here. So we say where the email is, and then whatever the user inputted. So we would put something like student@hatarget.com, and the password equals student in this case, and we would send that query, and now that the username and the password were correct, we would get a row and then log the user in as the ID 79 in this case. So this is how it looks like in practice. We have this email and the password here, and we sign in, and then we get logged in, and this is the SQL that was executed on the server, just as we typed in the console. But here the developer has made a terrible mistake. So they're building the query like this. So we take the beginning of the query, and then we start a string. String means a text data type in programming, so we just put something in quotes or in single quotes, and then it will be treated as text. So we start with the single quote, and then we just concatenate the email address that the user supplied, and then we add another quote and some more of the query. Then again we put a quote, and we concatenate the password to the string, and then eventually we just send that query to the database. Now the problem with this approach is that there is nothing preventing us from just putting our own single quote to the email or the password and terminating the string, and then we can start a new string or do whatever we want with the query. So we are injecting into the query, and we can modify the query structure. Let me show you an example. So here's the login form again, and now this time let's not log in with our student here. Let's just type some garbage in here and see that we will get a username and password incorrect. And now if we put a quote in here, then you will see that we are injecting into the query. We have added now a single quote here, and this is now where the string terminated, and then there was this quote in here that didn't really belong there, so we are getting this syntax error from the database. What we can do here is that we can say something like just terminate that string, and then we say something that is always true. So we say or 1 equals 1, and then we can just comment out the rest of the query here, and then we would go and sign in. And now this time we do get signed in as some random user who happened to be the first user in the database, because look at our query here. We are selecting from user, where email is la 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 la, that user probably doesn't even exist, and the password is ASD, also doesn't matter. But then we have the OR statement, and how the execution order works in a SQL query is that if you have an OR statement, it's first going to check if the left side of the OR statement is true, and if not, it checks if the right side is true, and if the right side is true or the left side is true, then we are going to return true for that row. So in this case, we returned all of the rows, all of the users in the database with this query, because 1 equals 1 is always going to be true, and the first one here happened to be this Eric here. So that is kind of the gist of SQL injection. When developers create these SQL queries unsafely by concatenating strings, then attackers will be able to inject into the queries and basically have full access to the database. Let's look at some exploitation techniques next. So perhaps the simplest way of exploiting a SQL injection vulnerability is to bypass access controls by modifying where clauses. So, for example, here we have an access control that is checking if the user ID is 73, which is of course my user ID. Now if I just do something like or 1 equals 1, and again comment out the rest of the query here, then we are modifying the where clause, and now we are returning all of the credit cards from the database, not just the ones that belong to our user. Now often we would like to access other tables as well, and for this there is a technique with the union query. So union works like this. We may have something like select 1, 2, 3, which is going to return 1, 2, 3. And let's say we are injecting here and we want to return something else as well. Then what we can do is put a union, select, and then whatever we want, whether it's 4, 5, 6 for example, and then we would have those returned there as well. Now there is a little limitation with the union, so you need to have the proper number of columns here. So if you just have something like select 4, 5, and on the other side you have 1, 2, 3, it's going to return an error saying that you have a different number of columns there on both sides of the union. So just be aware of that. And this is how it might work in practice. So now we would start putting here something like, we just escape the string, and now we start injecting something like union, select 1, 2, 3, and just comment out the rest of the query. And now in theory, we would get this 1, 2, 3 somewhere on those credit cards, but of course we get this wrong number of columns thing here, because we don't really know how many columns are there in this credit card table right now. So we might put something like order by here. So this is a little trick that you can use. So we start by order by 1. So now we are sorting the results that we get by the first column, and if we put order by 2, then we are sorting by the second column. And the reason I'm doing this is that we can know by doing something like order by 20, now we know that there's going to be less than 20 columns. Order by 10, we know that there's going to be less than 10 columns. Order by 5, that didn't give any kind of error here, so we know it will be more than 5. 8, it's 8 or more than 8, and let's try 9, and then we will know that it's actually 8 because 9 is now giving an error. So the 8 is the correct number. So the next step would be to add this union statement and then see if we can get some data there in the response. So we would add something like union select and then just 8 times null. So it is good to try with empty values first. We'll see how that works. Okay, we got this row here that we added, and all of the values are null or none as expected. And now we want to see which of these are reflecting somewhere here so we can see them. So we would try to put something like 1, 1, 1, 2, 2, 2, 3, 3, 3 here and see if any of those values reflects. And we can see that both of those 2, 2, 2 and 3, 3, 3. So this column here, the second column and the third column are reflecting, so they are probably the first name and the last name. So now all that remains is that we add the data here that we want to see. So we might do something like concat, which is to concatenate strings in MySQL, and we would put the email and this colon here and the password, and in the end here we would add the table where we want to retrieve this stuff from. So this would be from the user table. And now if everything goes well, then instead of the credit cards, then here we should see a lot of the username and password pairs here where the first name and the last name should be. Okay, so what if you don't know the names of the tables or the columns? So this is what you can do. You can select the table name and the column name from this information schema.columns table. So this is a standard table in MySQL, it's always there. And just add a little filter here that where the table schema, that is the database, is the current database. So you don't see a lot of unnecessary stuff here. And then you would just search for that. And then you will see that here we have this credit card table, card number, credit card table, card type, so on. And here we have the other tables and columns for the users and stuff. Injections can sometimes be in tricky places. So for example, if we now sort by last name, we will see that we are running this order by last name here, which is sorting these rows. And if we inject here, we can see that it is vulnerable. However, because we are injecting in an order by here, we can no longer use a union select. That ship's already sailed. We are too late in the query structure for using union. So we have to get a little bit creative with our exploitation approach. And one such approach is to use error-based technique. So the idea is that we try to get the data that we want to extract to reflect in these error messages. So if you are seeing these stack trace very verbose error messages on the page, then that exploitation technique is usually possible. So here is how it would work. So there are some SQL commands that can be used to work with XML, and they are perfect for our purposes because they show expat errors that we can use. So for example, we can do a select, and then we would select extract value. So this is one of the XML functions, and we would just give it some invalid value. This would really be like an XML string here, but we just put a 0 there for our purposes, and then here we would put something like smaller than, just to break the XML structure, and hello. And now if we look at the error message, we see that expat syntax error and for the hello. And now if instead of hello we would put something here like concat, and then well, let's put that there again, and then something that we would want to see, like for example, let's say the database version, then that should now show us the database version there. So we see expat syntax error and 5.7, which is the database version. So this way we can use the XML functions to trigger error messages that can show us stuff that we want to see. Now if we were to exploit this, we would just add a comma here, because we can order by multiple things, and here we would start the select extract value, and then we would add the 0 for an invalid value, and here we would just concat the smaller than symbol and whatever we want to extract. So this could be the version, for example, and then we would just close this query, and also we would of course have to comment out the rest of the query. So we would just do a dash dash space and send, and now we should see in the error here this expat syntax error, and here we see the version again. Now of course instead of the version we could check for the usernames and passwords and whatever we want from the database. But what if there is no error? What if we sort here by the last name and we put some la 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 in here, then we would just not get any results because some error happened, but we don't see the error message anymore. Then can we still exploit this? And the answer is of course yes, we can exploit it, but we have to get even more creative. So this is the plan. We do know whether an error happened or not, right? We don't see the error message anymore, so we cannot use the error-based technique, but we know that an error happened because we didn't get any results back. So what we're going to do now is that we're going to inject this conditional select here, which is the select if, which takes 3 parameters. The first parameter is the condition, and the second is what happens if the condition is true, and the third is what happens if the condition is false. And now what we're going to do in the condition is that we check if the ASCII value of the first character of the database version is smaller than some value, and then if it is smaller than some value, then we cause an error. So doing this select 1 union select 2 is going to cause an error, because doing a subquery that will return more than one row will always cause an error. And here in this third parameter we simply just don't cause an error, we just return 1, which is not going to break anything. So here we have a little script that automates this. So here's the URL. This is the query that we want. So we want to select the version, and this is how we would cause an error. And here we are just automating it. So we are sending the request, and based on the response length, we determine whether it was a true or a false guess. So whether we guessed right or wrong about the character, and then we just keep guessing until we get it right, and then we move on to the next position or the next character. And here is a simple binary search algorithm to just effectively get the data out. Let's try that. So we run the script. And there is checking false, false, true, true, false, and now we have guessed the first character is 5, second was dot, 7, dot, 3, 4. We got the data out. So that was called the blind injection technique. It's blind because we didn't actually see the data in the response, but we deduced it. In this case, we deduced it from how long the response was. If it was a long response, it had data and the error hadn't happened. If it was short, there was an error, so we knew the true or false based on that. You can always use the time-based technique as well. So in the time-based technique, instead of checking the response length, you check the response time, and instead of an error, you would cause a time delay. So there is a command sleep in MySQL, and you can just do like if true, then sleep for 5 seconds, and if not, then return immediately, and then you would know whether or not you guessed right based on the response time. But this is a really slow technique, and it's an error-prone technique, and it is really your last resort, but sometimes you do have to use it. So detecting SQL injection vulnerabilities in like bug-mounted programs shouldn't be very hard anymore once you understand how they work. You would input like quotes and single quotes and see if the application results in some kind of an error. If you have some integer like some ID, then you would try to put, if you have a value like 50, you would try to put in a value like 51 minus 1 and see if you get the record 50 back, which would also indicate SQL injection because the subtraction shouldn't be happening normally. If you have some sorting fields, then you would try to replace those with numbers to use this order by 1, order by 2. That would also indicate a vulnerability, and you would put these sleep statements here. So you would just try to kind of complete the SQL and try to add something like sleep 5 here. And if the application takes 5 seconds to respond, then you would know that there is a vulnerability. And there are some tools that you can use to automate both the discovery and the exploitation process, such as Sqlmap here. So you would just give it the URL and the parameters and the cookie and so on, and then it would automatically go and look for the vulnerability and also exploit it. The best way to prevent SQL injection vulnerabilities in your application would be to use an object relational mapper. So what an object relational mapper does, changes this into this. So you don't have to write SQL by hand anymore, and you shouldn't, but instead you're working with these nice code objects, and the ORM, the object relational mapper framework, is going to take care of all of the encoding and stuff for you, so you don't have to worry about SQL injection anymore. And then there is another option, which would be to use prepared statements. Not as good, but it is also possible to have a secure code base using prepared statements, but you just have to be careful, because with these prepared statements you still have these raw SQL strings here. You are just putting like places for parameters in those strings, and then you are safely binding those parameters to those raw strings, but still there is much more room for human error in this approach than with the object relational mapper, because with an ORM you wouldn't be working with these raw SQL strings at all. Now you need to remember to always use the parameter binding instead of ever concatenating anything, and with a very large code base it gets harder and harder to maintain this. So I would recommend go with the ORM approach if that is possible. Thanks for watching. This has been preview content from Hacking Academy. If you haven't already done so, go to hackingacademy.io and sign up. If you like the video, then leave a like and don't forget to subscribe. Happy hacking!